instance, and then we'll look at some ways that we can use these kind of, especially ways to put them together. We talked last time about there was this type that we cannot make an instance of mappy, aka functor, because right, functor is like things that kind of contain A's, and then we can turn all the A's into B's, right? But this thing, it doesn't really contain A's. A is actually an input, right? So we can't turn the A's into B's because it doesn't have any A's. It's like expecting us to give it A's, but having a way to turn A's into B's doesn't. So as an aside, I'm not going to go into this because it's kind of a tangent, but I just mention it if you're interested. There is actually a different class. You could call it like, it's called, well, it has different names. Like, you could call it like anti-mapping or something, where you take a function from B to A, and then turn a B A, like something A into something B. You can make this thing an instance of that. So if you have a B to A function, you can turn one of a BA into a BB. And I'll let you think about how that would work. But again, that's a tangent from where I want to go, so we're not going to talk about that. But let me make one more data type. We'll call it so this is just, I don't want to get into a lot about like what this means. It looks a little confusing, right? It's like, well, it contains a function, and that function will return ints, but you have to give it a function from A to int. If you give it a function from A to int, then it will return int. There's a couple ways we could think about this. I don't want to get into it too deeply, but you could think of this in terms of well, let me think of it this way. If you said to me, hey, I'm willing to give you an int, but if you want me to give you an int, then what you have to give me is a way to turn A's into ints, right? Then I might suspect that you actually have a value of A. Because if I give you a function for A to int, and you promise that you can then give me back an int, then probably you secretly have an A that you're going to put into my function, and then give me back the int that comes out, right? I mean, with int in particular, I mean, obviously you could do things like just return 6 or whatever, but that's kind of the intuition. And so maybe it seems like this kind of does contain an A in some sense, or maybe multiple values of A. Maybe you're going to put multiple values of A in here, get some ints and add them or something. So by that intuition, we might think, well, maybe we can make this an instance of mappy. Although if we look at this, we say, well, the problem kind of was that the A was on the left of an arrow, and it's like really on the left of several arrows, so maybe this isn't going to work. But we can just kind of follow the types and kind of see what happens and see if we can write something that works. Okay? So let's try it. And we'll just do this one together. I'll have you all do some other ones. All right. So I have my function f. I'm going to write down here what I have. F is a type A to B. And then I'm getting my Ka, so I'm going to pattern match on this. It's a Q. I guess I'll call this thing little q. And Q, so what type is Q? Little q. Yeah, it's this entire thing, right? So I'll just okay. And then let's see. You know what? We're actually going to, let's see. Just so that we, to make it a little easier on ourselves, we're actually going to make it easier by making it more abstract, because with int in the mix, we might be tempted to think about like adding things or like returning 0 or whatever. It turns out that's not necessary. And just to make sure we don't do that, we'll call this like, I'm going to add another parameter here. We'll say, no, it's not specific to int. It could be, any type you want. So now it says, hey, I'll give you an R, but you got to give me a way to turn A's into R's. And once you do that, I'll give you back an R. So now I need to say like, so now this isn't int anymore, this is R. Okay. So what I have to put in the hole is a KRB. So that's going to be, I'm going to need to use Q. Might as well stick that in. Now it says, yeah, you need to give it a function from B to R to R. So that's what we want. Okay. And I can just keep going and say, all right, well, the thing I want is a function, so let's just write a lambda and see where that gets us, right? So I'll call it lambda, I don't know, P. I don't know what names to give these because I don't really know what they mean. It doesn't matter. So now, right, P, so we wanted a B to R arrow R. So this, if we're making a lambda, this P is going to be this part. So I can say, all right, I've got P, which is a function from B to R. And now the whole is just an R. So now I just want an R. Okay. Well, now I can't really do much more to kind of break this down further because I just want an R. And now all I can do is kind of look at the pieces that I have and see is there a way I can put some of these together to get an R? What do you think? You don't have to come up with a complete answer. Just say like, well, what's maybe a way that we could get an R? I could use Q. Yeah, good. So, so Q and P both output an R. But if I use P, I'm just looking ahead slightly, I'm going to need a B. And it's less clear where I'm going to get a B from. I guess F outputs a B, but then I need an A, and I don't know where I'm going to get an A. Also, Q, Q is part of the input, so it seems reasonable that I should use Q somehow. I can't get away with just using P, because that was just like this thing. All right, so let's use Q and say, all right, well, if we apply Q to an appropriate input, that'll give us back an R. So I could fill in this and just say Q applied to something. Right? So now, Q says it wants an A to R function. So now we want A to R function. Okay? Any ideas how I could get a function from A to R? Well, see, we could either look at this and say, how do I get a function from A to R? Or I could go ahead and fill in a lambda there. Either way, what would you all like to do? Lambda, okay. Good. So I'll say lambda. I'll just call this lambda A subwhole. So now we have A has type A, and then what I actually want now is an R. So I'm back in the situation of wanting an R. So it seems like I haven't made any progress, except now I have something of type A that I can play with, and that's going to help. So any ideas? I don't want to use Q again because that would just I would just kind of get stuck in a loop just doing that over and over again. What else could I use? That's F. That's A into F. Yeah, I could put the A into the F, and that would give me a it kind of forwards and say, I got this A, I can put that into F, that gives me a B, I can put that into P, and that gives me an R. Or I could kind of go backwards and say, well, I want an R, P outputs an R, so I could use that. And what do I need to give it? I need to give it a B. How do I get a B? Well, F outputs a B, so maybe I can use that. I have to give it an A. I have an A. So, but either way, I end up with E of F. Notice here also, really what I'm doing here is I'm just composing P and F. Right? So P is a function from B to R, F is a function from A to B, and I'm putting them together to get an A to R function. So I could also alternatively have written, like right here, I could write like, that would also work. Okay, why did we do this? Partly, it's just a fun exercise in, like, maybe we don't really understand what this code does, but we can kind of follow the types and work it out. And once we get it type checked, then we're like, okay, well, at least the type checks. It turns out this thing actually does have practical applications. It's not just some weird thing that I made up. It's called the continuation functor, or it has to do with something called continuations. And I don't want to go more into that right now, but you can take my word for it that it is actually a practically important thing. And maybe we'll come back to it later. I don't know. We'll see where we get. Okay. So let's do something a little bit more. So let's say we have a list of ints, and we also have a function from int to bool, and I want a list of bools. Right? Seems sensible. I just want to go through and apply this function to every single int in there, right? So we'll call it. I don't know what we'll call it. Double map. So I don't just find some people around you and see if you can
It needs some parentheses, but other than that.
Okay. Does map to takes a function in the list. So does this? I guess this.
I'm trying to do it without composing it. Like if you do it without.
With parentheses.
Yeah.
Probably just be like parentheses. Probably just be like.
Yeah. Or just have it
Like this.
Yeah. Just have it.
All right, let's talk about this. So let's hear some solutions. So Joe,
We represent. We just said F.
okay, yep.
And then the list. I just call it ints.
Okay.
And then you can basically, if you call map once, you're mapping over the lists of ints within this big list.
Right.
So then you have to call it a second time to
Okay.
map over the elements within each list. It's map of map,
Right. So
which you, yeah, that works. Map, and then another map, F ints.
like that.
Or would it be map F and then
Map
F
takes
then?
it.
No. So if you just map F and then map F again, you're just doing the same function twice on a list.
Right.
So this is much closer. Let's come back to this, see if we can figure out. It's very close. Let's see if we can figure out which one. So, Joe, come with anything, or what did you all?
We did that, but we had the int part on the outside of the parentheses.
Ah,
And then,
like that?
yeah.
Okay.
And then it also suggested that we don't even need the ints there.
Right, okay, yeah, yeah. Yeah, so, okay, so let's think about what the difference is between these and why this one works and this one doesn't. So, map F ints. So even actually map F ints by itself, map F ints would say, take the function F and apply it to every element of the list ints. Right? But elements of ints are lists. And F is expecting a single int. So we can't apply F to elements of ints. Right? So what is this one saying? This is saying, all right, well, we're going to do something to every element of ints. Those elements are lists of ints. So what do we want to do to each list of ints in the list of lists? The thing we want to do to each list of ints is to map F over it. And then that'll apply F to each thing. Okay. You know, if you wanted to, you could say something like this. It's not necessary, but maybe it might make it clearer. Saying, all right, the function that we're going to do to each element of this list is we will take a list of ints and return what we get by saying map F over that list. But yeah, then whenever you have like a lambda that just immediately applies something to that thing, you don't need that. Right, here's another way to think of it. Remember that we said, all right, what is, map as a type like this. But we can also think of it, we can think of it as it has parentheses here, right? Map turns a function from A to B into a function from list of A to list of B. And so, map F is a function from list of int to list of bool. And then we're going to apply that to every list of ints inside this big list. We can take it even further, though. We could say, it's saying, not much, right? because I'm just saying double map f applied to ints is this other function applied to ints, I don't actually need to write the ints part. I can just say double map f is the function map f, right? So map f says take f, which is int to bool, and turn it into a function from list of int to list of bool. And then map f says take that function from list of int to list of bool and turn it into a function from list of list of int to list of list of bool. Right? So every time we keep applying another map, we like get kind of one more layer that we're putting inside. We could even simplify this. So if you think about what is this saying? This is saying we're going to take the input f and we're going to apply two functions to it. Exactly.
Yeah, could you write it as just map.map?
Yes, exactly. That's what I'm doing. So we could just write it as that. Right? Which you definitely have to twist your brain in a different way to understand what this means. But it's basically saying, right, we've stopped thinking about this as like something that takes a function and a list of lists, and we're saying, no, it's something that takes a function and it's going to give us a new function out. And what do we do to the function? We're going to do map on it twice. Right? And because every time we do map, it like lifts the function up to work on one more level of lists. Okay. How about, let's just say, so, well, okay, so we can also generalize this. One way we can generalize this is obviously this has nothing to do with ints or bools, right? So I could just make this A to B. So list of A is list of B. Right? That works. But it also has nothing specifically to do with lists. The map function is specifically about lists, but really, all the same argument applies to anything that is what we've called mapping, or is called function, right? So we could even generalize it further and say prime prime. Instead of saying map, okay, so as long as t is a functor, this is f map. So for example, if I have a function from int to bool, and I have a maybe m dot map char int, and I want a maybe m dot map char bool. Right, I can just say there's double map. Or if I could say f of foo of f equals f map. Well, so if I want to be explicit, right, I would say, here's my maybe map. And I just say, I take my maybe map and we're going to map. Well, I'm using the word map in two different things. This is a map like a dictionary, and then we're talking about mapping like functions. So this first f map kind of takes our function f from int to bool and turns it into a function from map char int to map char bool. So it makes it kind of operate on all the elements in the map. And then the second use of f map says, all right, we're going to take that and we're going to turn it into something that goes from a maybe whatever to a maybe whatever. So if we don't have a map at all, then it just ignores it. And if we do, then it goes and does the, yeah, and actually, right. So here, I guess I'm making it even slightly more general, because here, this says you have to have the same t, but it doesn't have to be the same t, right? So here this wasn't the same. We had a maybe, and then we had a map char. So we could even say functor s, functor t, something like this. So I don't know, like, I've got, just from list of Alright, so here's my, it's a maybe map from char to, well, any A, let's just say int. Right, but given that, let's give this a name. So if I call this my maybe map, right, I can say something like, and I want to say, all right, I want to add 1 to all the ints in here, right? So one way I could say that is fmap plus 1. Right, so I'm first going to say, here's my function plus 1, that's what I want to do. But then I need to lift that function up kind of 2 times. I don't just have an int, I actually have a maybe map of ints. So I'm going to do fmap twice, kind of lift it up to work on maybe maps. And then, so that works 36, 18. Or, you know, if I had nothing. What? Oh, right, okay, it doesn't know. That's enough. Why would it matter though? It's annoyed that it doesn't know, like it knows that this fmap is for the nothing, but it doesn't know what this fmap should be for. Like what type do you want there? But if I declared a variable with the type maybe map instead, something that I made that a nothing, that would work. Okay. So I do think we would do a triple map. So something like, well, let's say, you know, functor S, functor T, functor Q, takes an A to B function and then gets us from an S T of U of A to an S T U of B. How do you think I would implement that? Well, okay. So if I'm going to put parentheses like that, I need to give it like an argument. So I could say like, do that. Yeah, okay.
Also write it as fmap.fmap.fmap.
Yeah, I could do that too. So this works. I could also say triple map. Not F, just. Right? I can do this all day. As many times as I apply fmap, it just kind of keeps lifting it up one level. So this is an interesting way to, if I've got some kind of deeply nested data structure, I've got like, you know, a maybe list of maps of pairs of, you know. That sounds crazy, but like actually it's not that crazy, because if you're writing some complex piece of software, you know, you may actually end up with some kind of nested data structure. It's like, well, you know, I've got maps from, you know, characters to something because, you know, that represents kind of how many times this character occurs. But actually, I have a list of those because I'm kind of like trying a bunch of different things, and each one gives me a map. But also, you know, it could generate an error. So I have a maybe list. It's actually not that hard to imagine coming up with something like that. And so, and this is really just the tip of the iceberg. So I'm going to show you a few other things that we could do to like do things in deeply nested data structures. The rabbit hole goes extremely deep. There's a library called Lens, which takes these ideas and like runs with them very far. And you can do some really amazing things, like extracting pieces of deeply nested data structures, modifying things, all sorts of things. But so let's see one other thing, which is let's make a function called first that takes a function from A to B and a pair of an A and B and gives us a pair So, like, pairs are already an instance of functor, and we saw that when you do fmap, it'll modify the second component of the pair. But what if we want to modify the first component? I mean, we can just make our own function that does this, right? So this says, hey, if you give me a function from A to B, then I can kind of apply that function just to the first element of a pair and leave the second alone. So first f is easy, we'll just say first f of A comma E is f of A comma E. Okay? And now, let's say that I want to do something like this. I don't know what to call it. I already used food. Let's say I have a list of pairs of ints and chars. So let's say we'll call it int. So what I want this to do is increment every int. Does that make sense? So I've got a list of pairs, and I just want to go through and add one to all the ints inside those pairs. Okay. So see if you can write this code together. I mean, in your little groups.
Get the first element of the pair, yeah. And then just call this one. So,
Yeah.
yeah. If you call it once, then you're looping over the pairs. Fmap first of plus one. I think you can also write it as
Okay. Yeah, so just you can figure out exactly where the parentheses should go.
you should be able to use regular math. I think fmap's just for like general, like you don't know the type of it. So I think it would be the same. Because you know that it's in the chart. I feel like you could just use map here.
All right. So I think everyone figured it out.
Map.
So we can say
Go first.
map. We definitely want to map something. So now, once I've said map, I just need a function from an individual pair to an individual pair, and then that automatically apply that to every single list. And then, well, what function do I want from a pair to a pair? Well, I just want to do something to the first element of the pair. So I'll say first something. And now I just need a function from int to int. same because now I'm just saying, like, what function am I applying to plus one? I'm taking the function plus one and I'm kind of turning it into a different function. By saying, first, we'll do first. We apply first to it to get a function from pairs to pairs, and then we apply map to that to get function from listing. And, what was that? Yeah.
Could you write it doing map first from the right side?
What do you mean?
Map dot first. Or first dot map. But the plus one's on the left, so it'd be like plus one of first of map because you're mapping over it. Because I'm thinking, because you're like, it's the same thing with the annoyance of writing it from
Right.
right to
Well,
left.
Yeah.
But
I mean, you can make up your own operators that do like, backwards function composition or whatever, and then you could use those operators to write it in the reverse way. I mean, you can't, if you just write it in the backwards order, it's not going to mean the right thing. However, I want to see if I can convince you that this isn't as annoyingly backwards as you might think. Like, there's a sense in which you can read this and it kind of feels forward. So if you look at this type, and you're like, okay, I've got a list of pairs of int and char. So the first thing to do is to like deal with the list, because the list is kind of the outermost thing. So I'm going to do map to kind of like get inside the list. Now I've got a pair to deal with, and I really want to get inside the pair and look at the first thing. So I'm going to do first, and now I'm like focused on just that first element, and then what I want to do to that is plus one. So if you kind of think of it that way, it's not backwards. It is kind of backwards if you think about like, if you think about like kind of starting with an int and then like what do you want to do to this plus one function to build it up into this. But if you think of it the other way, it's like here's what I have, how do I kind of take it apart, break it down into smaller pieces until I finally am focused on the part that I care about, and then I do whatever I want with that.
I was thinking like first step was like mapping over something, which puts it at the very right side of the in a pipeline function. You put it at the very
Yeah,
far
right. I see what you're saying. If you think of it that way, yeah, then you would. Yeah, there's always multiple kind of perspectives to think about, because of course the order in which things happen is not so important in functional programming.
Yeah.
It's not about doing a sequence of operations in a certain order. It's about kind of describing the computation that we want. And then it'll do things in some order to make it happen, but yeah. So hopefully it should be clear that we can. So part of my point is like this is not actually specific. Like this thing that we did here was not necessarily specific to just fmap. There's other things, for example, like this first thing that let us anything that kind of lets us lift a function up into a function that operates on some more complex thing. We can kind of think of it the other way and say, if I have a complex thing, I can use this to kind of let me focus down on the part that I care about. So as another example, what's that? If I've got, a map, char, a list of things, pool. If I wanted to increment all the ints in here, right, using the same kind of approach, I could say, well, that is going to be, ultimately I'm going to do plus one, but I first have to sort of say how I'm going to drill down to the part where I want to do plus one. So, well, first I've got this map, so I can just say, since I want to do something to every element of the map, every value of the map, I can just say fmap. And then, let's put a hole so now that's going to show us what the hole is, but we know. So now we're focused on just the pairs, and I want to look at the first part of it, so I can say first. And then now I've got, I'm focused on this list of int, and I want to do something to every element of that list. So I could say fmap again, or I could say map. Might as well say fmap. Sometimes these are known as semantic
editor combinators.
There was a kind of well-known blog post where someone kind of explained this style and said, yeah, I like to call these semantic editor combinators. It's kind of like you think of it as you're editing this value. You have a value of this type and you want to edit it somehow. And it's like, this is like a little language for kind of describing where you care about, where you want to do your edit. And then you say what the edit is. And then other things than just fmap it first. So for example, if you have a, let's say result, here's an example, and actually, we'll see. So the idea is, what if I had a function from C to A, and I really want to edit kind of the output of the function. So I want to focus on just the output and say I'm going to do something to the output. Well, I can say if I have an A to B function, then it's going to let me turn it into a function that says, you know, turn a C to A function into a C to B function. Of course, I've called this result, but really, it's just function composition. Right? Because, well, how do I, if I have a function from C to A, how do I edit the output? The way I edit the output is just by doing another function on the output, after that function. That's just function composition. But, now I can do things like, if I've got, it's getting a little bit gross, but I can say, well, first I'm going to go into the map, and then I'm going to drill into the first element of each pair, and then I'm going to do something to every element of those lists, and then I'm going to just focus on the result of those functions, and then I'm going to add one to that. Naming it result kind of makes it clear that you're focusing on the result of type of a function. But really, I could have written, composition operator here. As we also know, that really is also the same as fmap for the instance that we wrote for like the arrow E instance. So I could actually just say fmap.fmap. That works also. Maybe maybe it reads nicer if you say if you find this result. All right. Any last questions? Yeah.
I have a question about mind blade.
Sure. Okay.
It doesn't say how to get level 1. It just says level 2.
Is that a problem? Do you rather get level 1 than level 2?
Well, I was just wondering what you have to do to get level 1.
So basically, you can only get level 2.
Oh.
I know, yeah. So sorry, I'm not doing that one. I thought about it, and I just couldn't think of any subset of it that made sense as because it's kind of like you're doing this. You have a goal, and it's kind of working you through this story of how do you get to the goal. And if I took out part of it, it's just well, you just didn't do the thing. So I just decided rather than. Also, I think it's it's not. So don't think of it as oh, it's really hard. It's the same difficulty level as other level 2 stuff. It might have made more sense to say it's only level 1 and there's no level 2, but that sucks because then we can't get it. So I just said. All right. See you all Monday. Good week.